7.1 Intro to Quadratic Relationships. So we have done linear functions almost since the school year started, and that's been our focus. What we're going to start doing now is a different kind of function, and these are called quadratics. Something that you guys definitely are going to want to know is that these U shapes, sorry, let me adjust my pen here. Okay, these U shapes that we see, you're going to hear me refer to them often as, write it up here. Okay, I'm going to say I refer to the shapes or to these graphs as parabolas. It might be a word you've heard before, might not be, but when you hear me say parabolas, I'm just talking about that U shape that we see on the graph. And what we're going to talk about in this video is just the different parts and pieces of these functions. And today's lesson is absolutely crucial for the next, 2 months of instruction about quadratics and just different pieces and parts. In today's lesson, we're just laying that foundation of what they are, what they look like, what their characteristics are. So let's take a look at this first example. And we're just going to kind of go through these different kind of pieces of a quadratic. The first thing we're going to talk about is vertex. All right, in this graph, the vertex is this point right here. So the vertex is a point, and it's either the lowest point, or like in the right graph, see how that's going to be a highest point? It could be either one, just depending on how the graph looks in your example. So in this case, it's our lowest point, and that point right there is -3, -7. All right, that point right there is -3, -7. And we want to make sure that we can always identify the vertex because it's really going to answer a lot of different kind of questions for us as we go forward. All right, so that's my vertex. Let's go ahead now and talk about whether it's a maximum or a minimum. Sometimes this can be confusing for kids, and so I want you guys to make sure you're listening. So I have my graph right here, and on this graph there is a lowest point. There's not a highest point. You see these arrows, right? They're going up and up forever and ever and ever. So they're going to go up forever. There's no highest point. But there is a lowest point, and that lowest point means that this graph has a minimum. All right, because we have a lowest point in this graph, we have a minimum. The axis of symmetry is this dotted line right here, and it's kind of interesting because on your calculator or, on most of the graphs that you're going to be given, this is not actually shown. It's more like this one. This is what your calculator would produce, okay? Your calculator doesn't show you the axis of symmetry, but it's there nonetheless. And it's this like invisible line that separates the parabola into two equal shapes. Imagine folding this in half along the dotted line. These two pieces would be touching. And that's what the axis of symmetry is it's just the dividing line for the parabola. All right, now it does have an equation, and since it's a vertical line, it's going to be x equals, and it always goes through the middle, always goes through that vertex, x equals -3. All right, now this is an important distinction to make. The axis of symmetry always matches up with the x coordinate of the vertex. All right, that should make sense. The dividing line should go through that minimum point, right, because that should be in the middle. Now the y-intercept is something that we've been looking at for a long time. Y'all, the y-intercept is the y-intercept. It's where your graph crosses, intercepts the y-axis. So in this graph, it looks like we're at 1. All right, so we're going to say 1, sorry, not 1, 0. That would be the x-intercept. We're going to say 0, 1. That's our y-intercept, 0, 1. All right. You know what? I'm looking at this thing right now, and I actually don't think that's the y-intercept. I apologize. That's my eyes messing with me. Let's see here. I think the y-intercept, let's see, this is the x side, the y-axis. So your y-intercept actually, let's say it would be up here. Let's just call it 8. I know it's not exactly 8, but just because our graph kind of stops every time there's a point right there. We're going to say the y-intercept is at 0, 8. All right, the domain and the range. Well, domain means all my x values, and this graph is going left forever. It's also going right forever. So my domain, my x values are all real numbers because it's going left and right forever. And my range, okay, well, we said it has this lowest point. So all my points go here and up. So we're going to say all the y values, right, start at -7, right? Down here, y is -7, and they go up. And the way I'm going to do that is I'm going to use an inequality. I'm going to say all the y's are greater than or equal to -7. They all are -7 or above. Okay, so these are the few basic pieces of information we need before we go further on into quadratics. So let's take a look at the next one. I'm going to go a little bit faster this time because you've already seen an example. The vertex in this graph is right here. In this case, it's the highest point. So my vertex is at the point -2, 5. All right, and in this case, like I said, it's the highest point right here. This is a maximum point, right? Because no other points on this graph are higher than this. This is the maximum point. The axis of symmetry is not drawn, and it usually won't be. You have to kind of imagine where it is. It's this dividing line right here. Everything mirrors from one side to the other, right? Everything's symmetrical around the axis of symmetry. It's going to be x equals, and even if I didn't have the graph, I should know it's x equals -2. How? Well, because the axis of symmetry line always matches up with the vertex, the x-coordinate of the vertex. But yeah, we can see that it crosses the x-axis here at -2, right? This is my axis of symmetry. Let's see here. Let's highlight everything just to kind of keep it color coordinated here. You guys, if you have me in class, you know that's something I do. All right, let's look at the y-intercept in this time. Hopefully it's a little bit nicer than the last graph so we can get a better example, and it is. All right, your y-intercept is right here. All right, and that point looks like we're at 3. So my y-intercept is at 0, 3. The domain, again, it goes left forever, right? And it goes right forever. So my domain is all real numbers. And just a little hint, when you have any kind of a quadratic, unless you're talking about a specific situation, like in a word problem, your domain is all real numbers. These graphs go left and right forever, each one of them. Your domain is all real numbers. Now the range, however, look at the graph. Okay, it looks like my y values start here and then they go down. So what are all the y's? Okay, well, they're either 5 or below 5. So how do we express that? Well, we say all the y values compared to 5 are less than or equal to that, right? They're at 5 or below, less than or equal to 5. All right, make sure that you can identify all 6 of these things for your quizzes today and just as a basis for the rest of this unit.